Hello all of you. Welcome to JG Chemistry. Guys, this is our fourth video for pericyclic reactions. In the previous video, we learned about the endoselectivity and stereochemistry of Diels Alder reaction. So if you are not familiar of endoselectivity and stereochemistry of Diels Alder reaction, you can refer the previous video. You can find the link of that video in the description box of this video. In this particular video, we will talk about the regioselectivity of Diels Alder reaction. Let's start. So let's say you have a diene given with an electron donating group and you have a dienophile with electron withdrawing group. As we know, diene act as electron donor while dienophile act as electron acceptor. So if your diene is having electron donating group, it is a good donor, and if your dienophile is having an electron withdrawing group, it is a good acceptor. And the position you can see here, it is one substituted both side, right? So if the reaction is given under thermal condition, there are two possibilities. It may be endo approach or it may be exo approach. So endo approach means you have to write down this electron withdrawing group on the dienophile towards the diene so that we can show the secondary orbital interaction which stabilize the endo transition state. And now about the stereochemistry, that you can see OMe is outside and the CHO is also on the left hand side. Outside means we consider it on your left hand side, and this CHO is also on your left hand side if you imagine yourself on the double bond. So if both the groups are on the left hand side means both are on the same plane. So you can say either above the plane or below the plane is the major product. And this is a 4+2 addition, so you are going to have a cyclic ring with a double bond. So stereochemistry we have covered, and this is a major product. And why it is so? We can also see if you do the heterolytic cleavage of the bond. So we can write plus minus. Why we have plus here? Because you have an electron donating group which will stabilize this positive charge. So like that we have written. Similarly, you can write for carbonyl, like oxygen can bear a negative charge. So carbon is having positive. Similarly, you have minus and plus here. So minus plus minus plus. So in this, plus minus forms a good combination. Proper combination is plus minus here, and therefore it is a major product. You could have think of this CHO, you can write on the other side, right? But so we will see that also on the other side. But before that, this is an exo product where you imagine the CHO is on the below the plane. Okay, so this is going to be the exo approach, and it is a minor product which we call trans. Okay, so now this is again endo approach. You have CHO written towards the diene, but you can see here CHO we have written towards OMe. Now CHO is here on the other side. The possibility is you can have either this product, but it is minor. Why it is so? You can see again we have written the heterolytic cleavage with plus minus. Now you can notice here oxygen is having negative charge, carbon is positive, and negative positive, and we know positive is an improper combination. Here minus is an improper combination. Therefore you cannot have 1,3 disubstituted product as a major. It is a minor product here. So this is where both are on the same side, or it may be opposite, trans. You can say exo approach. All the three products here are minor. The only major product is with endo approach, which have the stereochemistry, or both are on the same side. So this theory you can use for regioselectivity and to find out the stereochemistry of the product. For more detail about stereochemistry and endoselectivity, you can watch the part 3 video on Diels Alder reaction where I have discussed it in more detail. Then it is easy for you to understand this lecture. So in this problem, you can notice we have again a diene and dienophile under thermal condition. So it is basically 4+2 cycloaddition reaction. And now your diene is 2 substituted again with electron donating group, and your dinophile is with electron withdrawing group. So two possibilities, one with the regioselectivity and the other is with the stereochemistry. So we'll see that 4 plus 2 cycloaddition cyclic ring. One is you are having OMe and CHO 1,3 position, but it is minor. So we will identify why it is minor by making the same heterolytic cleavage. Now we will make the positive charge on the carbon where you have the electron donating group, so that it is stabilize this charge. So if you write positive here, you can write negative on the other side. Similarly, negative and positive. This remains the same. Oxygen bears a negative charge, so this carbon is positive. Then again you have negative, positive, and now you can notice negative, negative and positive, positive makes a improper combination. So therefore you are not having this as a major product. Improper combination. Now if you write on the other side, CHO you are writing towards the diene, so that you are showing the endo approach, where you have the secondary orbital interaction of this CHO group with the diene to stabilize the transition state. Now if you do so, you are having the 1,4 disubstituted product, which is a major product here. And why we are saying it major, you can notice the same sign here, having minus plus minus plus, same sign, but now you have negative positive and positive negative, which is a proper combination, and therefore it makes a major compound. And if you want to mention the stereochemistry also, you can see that the substitution here terminal is hydrogen, right? Both are hydrogen only. So with respect to hydrogen, you can write down for CHO, both are on the same side. So hydrogen, because it's not chiral, only one chiral center is there, so that you can write down either above the plane or below the plane. If they give you this kind of problem and you have to identify A and B, so let's see how and why we are discussing this here. So alpha beta unsaturated carbonyl compound is given in the presence of base and trimethylsilyl chloride. So we know the role of base. It will abstract a proton from the less hindered side here, which is going to stabilize with oxygen. Oxygen bears a negative charge, which will take this Me3Si. The silicon will give its electron. Okay, so oxygen will give its electron to the silicon by the release of Cl. So it get protected here. Now you can see this looks like diene, right? Your diene, which is 2 substituted diene, and a dinophile is given here with electron withdrawing group. So if your diene is 2 substituted, we get 1,4 as a major product, while if your diene is 1 substituted, you get a 1,2 as a major product. So that you can make a note. So here our diene is 2 substituted, 1,4 is going to be the major product, and you can draw this product as a final product. Again, you can verify the same theory by making the heterolytic cleavage plus minus and make proper and improper combination. So only this gives you a proper combination. You got the 4 plus 2 cycloaddition product. Now you have HCl. HCl on hydrolysis, it will regenerate the OH group here, deprotection, which will enolize or tautomerize to give you carbonyl. So finally you have the product having cyclohexanone derivative. They may give you a diene bearing a heteroatom. So this is again 4 pi electron, plus you have a 2 pi electron system. So 4 plus 2 under thermal condition. Since your oxygen is replaced with one of the carbon, so it is going to come inside the ring. So your 6-membered ring is having an oxygen and a double bond. Same regioselectivity you can explain to form this. So you can consider this 1 substituted, you will get 1,2 disubstituted product here. Or you can make the same improper and proper combination by negative positive combination and find out this as a major product. So this theory you can use to find out the regioselectivity after doing the heterolytic cleavage and find out the proper combination, and so you can design the final stereochemistry of the product. The other way, For easy reactions, if your diene is 1 substituted, you can say 1,2 is a major product. If your diene is 2 substituted, 1,4 is a major product. So I hope you will see this reactions and take the advantage of it for finding the regioselectivity of Diels Alder reaction. Happy learning. Bye.